Okay, so problem number 1 was 2 drops of nectar are needed to feed 5 butterflies. How many butterflies could be fed with 12 drops of nectar? How many drops of nectar would you need to feed 45 butterflies? Okay, so what you needed to be able to do for this problem was you needed to be able to see that there was a relationship involving multiplication between the numbers in the problem. Okay, you need to be able to try and visualise that in some way. Whether you actually drew the drops of nectar, okay, that's one way you could have done it. You could have used a table like the hotel floors problem we did a couple of weeks ago, okay, and that would have looked something like this. So N for nectar, B for butterflies, you would have been able to show that, so 2 drops of nectar equals 5 butterflies, and then you could continue that chain. So for every 2 drops of nectar, it fed 5 butterflies. So that could have looked like 4 drops of nectar, 10 butterflies. 6 drops of nectar, 15 butterflies. So from there, you had enough information that you could use to be able to solve the problem there. Okay, you could have kept going, okay, and you would have been able to see it was almost like 2.5 butterflies for each 1 drop. And you would have gotten to this point where you would have seen that 12 drops of nectar equals 30 butterflies fed. Okay, one way to be able to do it, if you're really looking for the multiplication relationships, or what we call multiplicative, where we're looking for multiplication, you would have been able to see, you would have had enough information by the time you'd done the first 6 to be able to see, okay? Because we know that 6 doubled equals 12. And you can see there that 15 doubled equals 30, okay? So that's one way you could have seen it. Okay, now to get to how many drops of nectar to feed 40 butterflies, you could have then seen that another 15, okay, would go in here to make our 45 butterflies. Okay, and that way you could have seen that if it takes another 15 to get from there, then you would have been able to see you could add on another 6 drops of nectar that equal those 15 butterflies. Okay, and that's how we're seeing that multiplication relationship. Okay, so you might have drawn a picture, and that would have worked just as well. You could also have used a table that will have worked also. Okay, once you drew that picture, okay, the onus was then on you to try and notice that relationship involving multiplication that this table showed really well. Another way that you might have been able to solve that problem, and you might be able to, or once you did some kind of table or picture, you might have been able to see this as well, is you might have noticed that you could see that 6 times 2 equals 12. So to go from these 2 numbers involves multiplying by 6, and that meant you could look at the butterflies and go, well, 6 times 5 equals 30. So for 12 drops of nectar, okay, there must be 30 butterflies. Okay, and you could have then noticed that if 45 butterflies, okay, so for every 45 butterflies, okay, and I happen to know that there are 9 lots of 5 in 45, so that meant 9 lots of 2 drops of nectar. Okay, and so 9 times 2 is 18 drops of nectar. Okay, so that's another way that you could have used multiplication to solve that. Okay, so problem number 2. I was talking to someone today about multiplication and division, and when I told them that 12 shared between 3 had the same answer as 3 times 4, he told me that I was wrong and it was actually the same as 3 shared between 12. Who's right? Draw a picture and explain a story for your picture to prove it. Okay, so hopefully you could see that both I and the person I was talking to were wrong. Okay, we were both being ridiculous in what we said. Okay, and hopefully you thought of an array as a good picture to be able to show how we were both wrong. You might have done something like this. Okay, so this was the first thing that I said, 12 shared between 3. So here's your 12 objects. You could have shared them between 3 and gone, well, there's 4 in each group there. Okay, but then when we look at doing 3 times 4, we can actually see that even though there's the same number of objects, because the situation is different, okay, the answer is going to be different. Okay, so 3 times 4 here because 3 lots of 4 equal 12 altogether. Okay, so over here we've got 4 in each group, whereas over here we've got an answer of 12 altogether. The person I was talking to who said that 12 shared between 3 had a totally different context to what I was talking about. So he was talking about having 3 whole things, okay, shared between 12 groups. Okay, so he would have to cut up each of his 3 objects, okay, into 12 pieces altogether. So we kind of know that if there are 3 objects shared between 12, then each one must be cut into 4, so that there are 12 pieces altogether. Okay, so notice how for each, so 4, 8, 12 altogether, but notice our answer isn't actually going to be a whole number. Okay, so for example, if you think here this might be 12 cookies shared between 3 people, each person is going to get 4. Okay, this might be 3 people, each have 4 cookies, there are 12 altogether. Okay, whereas this one, okay, this might be 3 cookies shared between 12 people. Okay, it's going to have a different answer, and that answer is going to be some kind of fraction. You might be able to see what fraction each person, fraction of a cookie, is going to get. Okay, and I hope that they're big cookies, otherwise you're not getting much of a cookie there. Okay, so you might be able to see that in this person's context, each person is only getting a quarter of the whole object each. Okay, so hopefully you're able to use a diagram and picture something along those lines to be able to prove that we were both being ridiculously wrong. Okay, good job to those who were able to solve that. Okay, problem number 3 now. My car is supposed to use fuel at a rate of 8 litres for every 100 kilometres that I drive. If I go on a road trip and my car uses 36 litres of fuel to drive 400 kilometres, is that more, less, or the same as what it should use? Okay, so I gave you a hint in the video that you needed to think about the relationships between the different numbers in this problem. Okay, so you needed to be able to think about what you could see in the numbers that were in this problem. Okay. One way you could have done it was to draw a table like you did with the nectar and butterflies. And that might have looked something like this. You might have seen that there was a relationship between the 100 kilometres and the 400 kilometres that you could use. Okay, and you might have checked it by doing something like this. So if 8 litres takes you 100 kilometres, you might have seen that 16 litres will take you 200 kilometres, 24 litres take you 300 kilometres, and 32 litres should take you 400 kilometres, which is actually less than the 36 it did take. Okay, you might have been able to remember your doubling and eliminate this step altogether. Another way to do it is to use, or another way you could have done it, would be to use what we call a dual number line, okay, where we have one thing that we're modelling on the top of the number line and the other part of the problem that we're modelling at the bottom of the number line. Okay, so for example, the 2 zeros mean the number line starts at 0. Okay, you might have had the litres at the top and the kms at the bottom. Okay, and you might have gone one step where the litres is 8 and the kilometres is 100, another step where 16 kilometres gets you 200 kilometres, 24 takes you 24 litres takes you 300 kilometres, and 32 litres takes you 400 kilometres. Okay, and you could be able to see there that multiplication relationship of 100 times 4 equals 400. Okay, and so that also relates to 8 litres times 4 equals 32 litres as well. Okay, so hopefully you used a similar strategy, okay, to be able to work that out. Well done on your work with the problems today. Look forward to seeing what you can do with the problems tomorrow. Catch you later.